My name is Abel Gray Kantuma. I'm from GREYTEST CAD Design Concept. This is actually my WhatsApp contact. You can reach me on this number. You can call me. Okay. These are the list of softwares which I have covered on our YouTube channel. They are very much available on that channel. Visit the link down below the description of this video. You'll find a link to that channel. Visit that link and actually keep yourself busy. Okay, we don't teach all of these softwares on our Telegram platform, where we give you the software, we'll guide you on how to install it and how to crack it on your system for free. Okay, we train you through the process of using each of these softwares for 40 days just for a token. Okay, just for a token, we'll guide you through that process for 40 days. You can DM me. Okay, today I'm going to be showing you how to actually come up with a frame that is your column and your beams on your Staadpro. Okay, this is actually going to be episode 3 of this training, which is actually in series. Okay, we are going to be creating a new project. First of all, you must actually configure where you do your settings for the code of practice, and then the unit of measurement, and then okay, and then unit of your forces. Okay, all of those settings, you do them from your configuration here, which I have covered that in the introduction part of this training from the episode 1. Okay, so when I click on a new project, like like I told you, STAAD is actually means structural analysis and design. That is the meaning of STAAD. And then the pro is actually program. Okay, I'm going to tick on space and I'm going to name this frame. Okay, and then I can choose a direction where to save this design once I'm done. So it will automatically go and save there. So you can actually select a directory for that. Okay, good. So everything okay here. I click on yes. Click on yes. Now I'm going to add beam, like I told you from the beginning. The beam covers both the column and then the beam itself. Okay, white plate is actually for slab. We're going to go into that on the next video episode of this training. Okay, so I'll click on finish. Now this is the window. The next thing I'll do, I'll go on to my geometry. Okay, so I'm going to close this. Now this is actually the frame we are actually going to come about, where we have, this is our column, this is another column, this is another column. This has a fixed support, this also has a fixed, and this is actually a pin. Okay, now the difference from here to here is actually 1 meter. I have explained from the beginning this axis, where we have upward is positive, downward is negative. This is Z negative, Z here, positive going this direction. This is positive going this direction. This is negative going in this other direction. Now good. You can see at this point we have a uniformly distributed load. Here we have a pointed load, and here we have a varied load. So good. Coming back to our software, to do that, which we have explained earlier on, we have our 0, 0, 0. So we have as it is here, you can see your 0, 0, 0. This is X, this is Y, this is Z. Now this is actually going to be our starting point. In Staadpro, you have to actually assign your nodes. Okay, your node are actually like your joints or your points. Okay, so we must create nodes for all of these joints. Okay, in order to actually model this, okay, beams and columns in the software. Now to do that, our first point here is this. So we assume this to be our origin. This is where we are starting from. So at this point is going to be 0, 0, 0. Now if that is correct, I will input that value here, 0, 0, 0. So once I type in 0 and I click on enter, it assumes everything 0. So the second point, you can see the node here on our screen, on our window, showing us. If you look down here, you can see we have our X, we have our Z, we have our Y. Okay, good. So the second point is actually going to be at this point, which is vertical. Okay, this is okay at this point, which we have a height here, because from here to here you have to go through a height, so which is a vertical, a positive. So this is upward, so which is positive. At this point here we have 0, height which is 3, and then our Z is actually 0. So we are going to have 0, 3, and then we have 0. Good. So we have gotten our points, our first point here and our second point here. Now to get for this point, this distance from here to here is actually 3 meters. So all I have to do here is to come here and type in our Y, which is actually 0, and then sorry, our X at a distance of okay, so the distance is actually 3 meters away from this, okay, and it's also at a height of 3 meters. Okay, so it's going to be 3, and then 3 as well. Okay, so our X, the distance from the distance from here to here is 3, and then the height also is actually 3. I have explained this in the previous episode where I explained the different phases of your Staadpro. Okay, so once I click here, I can make this in the Z phase. Okay, so you can see here now you have it all straight up. So I can actually copy this instead of imputing the value. You can see I've not been able to pick this point, is because I have to come here and pick on node cursor. So once I click on that, I can highlight this, and then I can copy and then paste. Now to paste this, it's actually going to be -2 meters. Okay, but not in, you know, it's actually y direction, so -2 meters in y direction. You can see it here. Now the difference between this point and this point is 1 meter, so that actually means that from here to here is actually 2 meters. Okay, so I can do the same for this. Okay, but let me just impute this value from here. So at this point here, we have from here to here is actually 6 meters. This point here is 6 meters. From here to here is 6 meters. So it's actually at 3 at 6 horizontal, 3 vertical, and Z is equals to 0. So it's 6, 3, and 0. Okay, good. So if we come down here, I can as well copy this and then paste this node, and then this is actually going to be -3 meters. Okay, which will take it down. Okay. Sorry, I'm inputting this value. Paste notes. Okay, I'm taking it down, which is -3, y-axis -3. Okay, I don't want this to actually waste much of my time. So at this point here, I have 6 here, I have my y is 0, and then I have my z is actually 0 as well. So I have all of my value very much correct. Okay, so after getting this, the next thing we'll do is more like the first design which we did on our beam design. So the first thing we'll do is to define the nodes, which we have done that. We are going to add beams to this. Okay, as you can see here, this is add beam, and you can also use here and come down here to add beam. Okay, so I'm going to be using the one here, which is actually the same with the one you know already before. So I'll just keep clicking. Okay.
So click on OK to get this point.
So at this point now, the next thing we are going to do is I'm going to define the section of this beam. Now to do that, if I come down to my general here, you can see I'm already in my section. Okay, at this point I'm in my section, so all I will do is just to so if I define this, you can see different shapes. Okay, we have T, we have trapezoidal, we have general, tapered. Okay, so I'm assuming them all to be rectangular. Okay, so I'm going to be using a 230 by 450 beam, and I'm going to be using 230 by 230 column. So I'm going to define that for my column is 230 by 230, and I'm going to add, and then for my beam is going to be 230 by 450. Sorry, so this is going to be 450, and this is going to be 230. So I'm going to add that as well. So I will close this. Okay, so after defining the section for my beams and my column, okay, so I'm going to highlight on the beam. Okay, now it's just for me to assign the sizes of these beams and this column to each of this member. Okay, so we may have some of these structural members that may vary in size. Okay, but in this design I'm going to assume all the columns to be of the same size and all the beams to be of the same size. So now I'm going to highlight all of my beams, and then I'll click on this section, which is 450 by 230, and then I'm going to assign to selected beams. Okay, and then I will assign. Now it has assigned that, so I'll come down here, select my columns, and then I'll pick on the section first, before selecting on my columns, and then it's already on assign to selected beam, and then I'm going to assign. Now my section has been assigned to my beams and my columns as well. So after doing that, the next thing I'm going to do is actually to assign a support to these structural members. Okay, so but then as you can see, our nodes here have actually disappeared. So I can just come down to my symbols and labels, and then node numbers. Okay, and then beam numbers as well. I can just apply, and I click on OK. Now you can see the numbers have actually popped up on each of them. Okay, so I'll just go to my support, which I have here. If I click on my support, I'm actually going to create two different support from my design here. I have a fixed support and I have a pin here. So I'm going to create a support. Now on fixed here, you can see everything here has been checked by default for us for fixed support. So I'm going to add that. So I will create again and come to my pin support, and I'm going to add that as well. Now this is actually my fixed support, and then my node here is cursor here is activated, so I can just come here and place my support, my fixed support, assigned to the selected node, and I'll assign that and I'll click on yes. Now you can see that my fixed support has been added to this. Now I have both pin here. Let me check from my diagram. I have a pin at the middle here, so I'm going to make this safe. So I'll make this fixed as well, and then I will assign and I'll click on yes. So I'll click here where I have my pin, I'll click here and I will assign. Now all my support has actually been assigned to all the members. Okay, so after assigning my support, the next thing I'm actually going to do is to actually create my loads, okay, and definitions for this. Okay, so all I will need to do is to go to my load and definition. So coming down to my loads, I'll just click on my load cases and I'm going to add this. So I'm going to add my dead load and I'll name it dead load, and I'll click on add. I'll go to my life, I'll name it life, and I'm going to add. And then I'll close this. So if I come down to my dead load, I'm going to add this. I'm going to add self width, like you know, which I have explained in my previous video on episode 2 of this training, self width. Okay, so I'm going to add and I'll close. And now you can see the self width showing me a question mark, showing that this self width has been provided for, but it has not actually been applied to the structural members. Okay, so I can just click on this self weight, and then I'll assign all of these to my view, and I'm going to assign. Okay, so once I click on assign, it's going to assign this self weight to the whole structural members, as that is actually here. Okay, so I'm going to click on assign. Now our self weight has actually been added to this. So the next thing I'm going to do is to go to my life load. Our life load is actually more of like the impose load. Okay, so if I go here and then I click on add, now if I come down to my member load, okay, if I come to my concentrated force, okay, as you can see from the diagram, here we have a concentrated force, that is a pointed load acting, okay, which is 15 kilonewton. Okay, now as you can see, from here to here is actually at 3 meters distance. Okay, this covers 3 meters from this point now down to this point. So we have a value of D1 and D2. Okay, so I'm going to type in 3, which is actually the point where we have our pointed load. Okay, so it's at GY, which is global Y. Okay, and then the value for that load is actually minus 15, because it's actually acting downward. So I'm going to add this load. So I'll go to my linear varying, okay, where I'm going to click on this, because you can see from my diagram here, this is actually the shape of this load. So not this one, it is like this. So I'm going to leave it at X, okay, and then the load is actually let's check that value for this load, is actually 2, okay, which is actually going in an opposite direction, is actually going in -2. So I'm going to add that. Okay, so that has been added. So the next load is our uniformly distributed load, which is actually at this point here. Okay, so our uniformly distributed load, which we have for a value of let's see 6. Okay, so I'm going to make this -6 GY. Okay, so our D1, D2, everything is actually 0. So I'm going to add that. So lastly, the last load here we have is the varied load, okay, which is so we'll come down to our linear varying, okay, where we have the value for W1. Okay, so this value is actually at minus 9. Okay, so it's actually 9, so I'm going to make it 9. So at W1, you can see this is W1, this is W2. So W1 is 0, W2 is -9. Okay, good. So I'm going to add that. Now the direction for this is actually at y direction. Okay, so if you love what you are seeing, make sure you like this video, give it a thumbs up, subscribe to this channel, it's actually free. Click on the bell icon so as to always get a notification whenever I post videos. I post videos like this on a weekly, sometimes on a daily, so encourage as many that wants to have a deeper insight of design. So I'm going to actually add this. Let me see if it has been added. How many load do we have here now? I have myself with 1, 2, 3, 4, 5. Okay, so I'm going to close this. Now good. Now I have all of my load that are actually here. So all I need to do now is to place each of these loads at where it should be. Okay, so my self weight has already been added to all the structural members. Now I have the concentrated load, which is this. So all I need to do is to assign concentrated load okay. Okay, I'm going to use cursor to assign this. So I select here and I assign. Okay, sorry, I think that is not correct. Okay, I have my concentrated load. Okay, let me select this beam, assign to the selected beam. Okay, this is actually the beam. I assign to this selected beam, assign. Okay, assign to the selected beam, and I click on assign and I click on yes. Okay, now good, this is actually what I'm looking for. And then I have assigned my concentrated load, and then my uniformly distributed load, I select my beam and then I assign to the selected beam and I assign and I click on yes. Okay, let me check this diagram. I hope I'm doing the right thing. Good. Now here I have my varied load. Okay, this is linear. I'll select here, I'll assign and I click on yes. No, I think this is not it. I think one load is actually missing here. This is uniformly distributed load. This is 6. Okay, one load is actually missing, which I'm going to actually create that. This is 6. Let me check from my diagram. Okay, my 6 is uniformly distributed load. This is 2. This is 2 linear. So I click on this member, and then I select, and then I assign. Okay, good. Now this load is actually what is remaining here, so I can just add that load right now. Okay, I have okay, click here and I add. Okay, I come to member load, linear varying. Okay, I make this -9. Okay, at y. Okay, this is 1 is 0. Okay, everything is okay, and I click on this and I close this. Now this is the value I'm looking for. Now once I click on this, I assign to a member, and I assign this, and I click on yes. Now good, this is actually what I'm looking for, and I come here, beam members, points, orientation, specifications. Okay, I'm going to apply orientation, support, dimension, member numbers. Okay, notes, dimension, support, points, specification. Okay, so you can add whatever you want to be seen on this diagram. So whatever I check on, it's actually applies on that. I'm going to take off dimension, beam specification, beam numbers, note points. Okay, what I want to see is for my load. Okay, okay, is for my loads. Okay, so node numbers, I just want to see the load value. This is actually what I'm looking for, and I click on OK. Now you can see all we have here. These are different loadings on each of this structural member. Now after this, the next thing I'm going to do, I have actually inserted my support. Okay, so the next thing after my load and definition, which I just finished, I'll go to, I have assigned all the loadings, which is I'm almost done with that part. I'm going to define the material for this. All I need to do is just to go to my material here. I'll click on a concrete member. Okay, so on my next video I'm going to be showing you more on how to actually come about defining these parameters for your concrete. Okay, the characteristic strength of your concrete, and then the characteristic strength of your steel. We are going to be designing for this concrete itself. Okay, you can specify your material here. Okay, now good, I'm going to close this. Now I'll go to my analysis and print. Now at my analysis and print, I'm going to leave it as no print, and then I'm going to add, and then I'll close. Now you can see your performance analysis here, load, to load type, and all that. Everything is actually shown here, and then I'll close on this. I'll go to my analysis and I will run my analysis. Yes, I'll click on save to run my analysis. Now you can see I have 0 errors. Now if I have errors on my design, I may most likely actually not be able to go through my post-processing. Okay, so I can view the output file to actually see what we have here. Good. Now this is actually our output file. Okay, good. So after doing my analysis, I'll go to my post-processing, and then you can see my dead load, you can see my live load. If I take it off here, it's coming under my available. If I take it back here, that means I have selected I'm going to be using both this live load and this my dead load. On the next video, I'm going to be showing you how to actually apply some of this load using your factor of safety. Okay, so I'll click on apply and I'm going to click on OK. Now you can see we have at horizontal, at vertical, at horizontal, resultants, rotational, every value here that you can see. For your displacement as well, you can see all of those values here. Now if I click on my axial force, you can see this is for my axial. If I click here, you can see this is for my shear at y, this is for x. Okay, you can see this is for moment. Okay, now you can see my shear force and your bending moment diagram here. All I can take off some of this, so you can see your shear, you can see your bending moment. Okay, at y, at x. Okay, beam stress. Okay, this is deflection. Okay, so if I go under my result here, I go under view value, come to my beam result. So before then, let me make here, I come here and I annotate this. You can see what I have, the maximum bending moment. Okay, at maximum. Okay, you can see your bending moment at the midpoint. You can see your bending at the end. Okay, you can come down to your shear and check for shear at the maximum, check for shear at the midpoint. Okay, now good. I can even combine stress here. Take this off. Let me see. Check for this. In order to annotate axial force, you must have axis diagram on. So I have to turn on my axis diagram from here. Okay, in order to view that. So if you love all that you have seen, make sure that you actually like this video. Make sure you actually give it a thumbs up. Okay, so click on the bell icon so as to always get a notification whenever I post videos. Okay, I post videos like this on a weekly, sometimes on a daily, so as to encourage as many that wants to have a deeper insight of design. Now you can see for each of this member, you can actually view the property for that. All you need to do is just to come to your beam selection, your beam cursor. You select on any of these, because this actually calls even your columns as beams. Okay, so because your beams, your column is more like your beam as well, but it's actually vertical. Okay, so this normal one we call the beam is actually horizontal, this is actually vertical. Okay, so you can actually view the reports for your joint displacement. At your displacement, you can view for the beam property. You can see the cross section area for this particular beam. You can review that, and all of this, each of these structural member. Okay, make sure that you actually stay safe, and then make sure that you stay blessed.